Hello viewers, today I am discussing how the hysteresis losses takes place in the transformer, and most of the people may have a doubt about the hysteresis losses, and today I will clearly explain how the hysteresis losses will take place. So this is nothing but a BH curve. So y-axis I am taken as B, and x-axis I am taken as H. H is nothing but magnetic field intensity, B is nothing but magnetic flux density. So if the external voltage applied to the transformer core, external voltage applied to the transformer core, it will establish alternating nature of EMF due to the flux. So I am dividing this alternating wave into some parts, A to B and B to C, C to D and D to E and E to F and F to G. In the same way, this BH curve also I divided into same group. This is A to B, B to C, C to D, D to E and E to F and F to G. This is most important one. You should compare everything. So according to domain theory, if external force applied to the transformer core, magnetic domains in the transformer core, until you apply at this point zero EMF, nothing but zero external force applied to the transformer core, so that the domains available in the core will be in random direction at this point A, nothing but this is point A. Now if external force increases in this direction A to B, the domains will align in a particular direction like this, particular direction. So if the domains are in random direction, it occupies less place. If the domains are in a particular direction, it occupies more place. So this is at point B. This is. So this is at point B. This point. Now this is in this direction. Now the force is in this direction. So if the force is changes from one direction to another direction, definitely the domains also changes its orientation, its direction. So due to the this force, the domains will changes in a random direction, but due to the retentivity property of a core or any material, some of the domains will not change its direction. Look at this one. At the bottom, some of the domains are in the same direction as previous, and the remaining domains are in random directions. This is due to retentivity property of the material. So these domains are in aligned in some direction, nothing but at this C, at point C, some domains are in same some direction. Some direction is nothing but definitely it is having some magnetic field. Here electric field is zero. So same way here C, at this point C, look at the C point at BH curve. This is point C. At this point C, look at this one at origin. H is 0, B is exist. B is exist. So we should take B on y-axis. This is H. So at this point C, B exists, but H is 0. Magnetic field intensity is 0. B exists because B is nothing but flux density. Flux exists. Flux is due to these aligned domains. Due to the retentivity property, these domains will remain stationary like this one. So flux is flux, some flux exists, magnetic field intensity is 0. So to eliminate to to eliminate these flux, we should apply the same force in this direction but in the reverse direction up to C. If you apply the force in the reverse direction, these domains also will be in random direction. This is at point D. So at point D in the alternating current, alternating uh, sinusoidal waveform, and same point at D. Look at this one at this point D. So look at this one, only at H exists but B is 0. Y axis B is 0, and on X axis B is 0 but H exists. H exists, B is 0. B is 0, nothing but domains all are in random direction. But H exists. Why H exists? Because the force is there at point G, negative force is there, so that negative magnetic field intensity will exist in this direction. Now, if D to E, alternating current, alternating EMF changes from D to E, nothing but here A to B. If A to B, then the domains are in this direction. Here, this is in this direction. Now, the force will be in this direction. So, definitely the domains in the reverse direction of the previous one. This is it E. This is D to E. The domains will be in reverse direction of B. So look at this one. Where is the E in the BH curve? This is E. So this is B at B positive and at B negative. So that's why these domains are in reverse direction. Here at B right side, this B at C reverse direction. So now the alternating wave changes from E to F. E to F. So D to E nothing but in this direction. E to F is nothing but the direction will be changes. So the domains also we should change the direction, so that these directions to this, before changing the direction, the domains will move in a random direction. But due to the retentivity property, some of the domains will remains in the same direction. Look at the bottom. So these domains are in this direction, right to left. These domains are so some right to left. These domains will remain stationary, same direction, due to the retentivity property of the material. So at point F, at point F, look at this one. At point F, from the origin, look at this one. Y-axis only flux density exists, H is 0. Flux density exists, H is 0. H is 0 is nothing but electric field intensity is nothing but EMF is 0, but y-axis some negative flux density is there. So B, negative B is due to determinativity property of these domains. And to eliminate the orientation of these domains, we should apply the positive force in the same direction like this. Positive force in the same direction like this. Same as the previous one, you should apply the positive force. If you apply the positive force, all the domains will be in a random direction. That point is called G. At G, look at this one. At G, all the domains are in random direction. So this is nothing but a BH curve behavior, and due to the alternating nature of the EMF, and this process will be continued for every cycle. For every cycle, this process will be repeated, and this BH curve will be like this continuously. So generally this arrow will be like this. So the always loop will be continuous for every cycle. This loop is for one cycle. Like that, for every cycle, this loop will be continuous, and this is nothing but due to the alternating nature of the external force, the BH curve takes place in the transformer core. Fine, everything is over, but why the hysteresis losses takes place? That is our question. How the losses will takes place? So, if you, according to domain theory, we observe that due to the random direction, the rectangular area is less. If domains are aligned in a particular direction, the area will become more. So generally, for example, if all the peoples are uh, standing in a random direction, the occupied place is less. If all the peoples are aligned in a particular direction, definitely the area will be increases. And due to this changing area, changing dimensions from small rectangular area to large rectangular area, nothing but from this position to this position the expansion, and this position to this position again compression, then this position to this position expansion takes place. That is, for one cycle, compression, expansion, compression, expansion of transformer core takes place. So these domains are available in the, these everything is done on transformer core. So due to this BH curve, nothing but magnetic hysteresis. This is nothing but magnetic hysteresis. Due to the magnetic hysteresis curve, the dimensions of the transformer core is changes. So this compression expansion, due to this compression expansion, some force will exist, some force exists on the transformer core. The transformer core also compression and expansion takes place. Due to that mechanical pressure, due to that mechanical pressure, some losses will take place. Those losses are called hysteresis losses. So due to this compression and expansion, some magnetic magnetic some magnetic noise will be produces, some magnetic noise will be produces. This is called magnetic hum. This is called magnetic hum. This magnetic hum, due to this magnetic hum, some sound will, some sound will some sound we can listen if you stand in front of the transformer. So generally everybody might listen the sound if you from the transformer. That sound is due to this magnetic noise, due to magnetic hum. This is due to the transformer hysteresis losses. So these are the major losses which results the magnetic sound. So these are the losses how that takes place in the transformer core. And so the transformer hysteresis equation is WH is equal to K into B max whole power 1.6. 1.6 is for CRGO, steel only. The transformer core is made with CRGO steel, cold rolled grain oriented steel. This is the expansion of CRGO steel. This is the special purpose steel. So this hysteresis losses. So we know that EMF equation E is equal to root 2 pi Fn phi. Phi in place of phi we can write B max into A. So 2 pi constant, N constant, area of the core is constant. Area of the core is a constant, so that E can be written as K times of F into B max. From this one, B max is equal to, B max is directly proportional to E by F. So E by F. If E by F is variable, if E by F is constant, this total will be constant. K into B max will be constant. B max whole power 1.6 will be constant. Hysteresis losses directly refers to frequency. If B max, look at case 1, I am assuming B max is constant, nothing but E by F constant, then hysteresis losses K B max whole power 6 also constant. Now then hysteresis losses only directly proportional to frequency only. This is for case 1. I assumed E by F ratio is constant. Now in second case I am assuming E by F ratio is variable, nothing but B max is directly proportional to frequency and E by F only. E by F. If I substitute B max is equal to E by F in the hysteresis equation, that becomes hysteresis equation becomes E by F whole power 1.6 into F. So which is equal to hysteresis losses is directly proportional to, so denominator 1.6 F is there, numerator F is there. So e power 1.6, e power 1.6, denominator 1, 1 by F power 1.6, numerator F is there. F will be cancelled, we will get F power minus 0.6 only. So this is the relation if EMF and frequency variable, then hysteresis losses is directly proportional to EMF and inversely proportional to frequency, because minus is there. Minus is there. So case 3 I am assuming E is constant, F is variable. E is constant, F is variable. So that I can write as B max. I am taking new pen. So B max is directly proportional to 1 by inversely proportional to 1 by F only, because I assumed in case 3 E is constant. E is constant, so that B max inversely proportional to 1 by F only. If I substitute B max is equal to 1 by F in the hysteresis equation here, so hysteresis equation becomes 1 by F whole power 1.6 into F. So hysteresis losses becomes 1 by F power 0.6. Nothing but if frequency is variable and E is constant, then hysteresis losses inversely proportional to frequency. If the frequency is decreases, hysteresis losses increases. This is case 3. For case 4, I am assuming F is constant and E is variable. Then we can write this equation as B max directly proportional to U only. So if I substitute B max is equal to E in the hysteresis equation, hysteresis is directly proportional to E power 1.6 only, because frequency is constant. So hysteresis equation, in the hysteresis equation frequency also this is constant. So only hysteresis loss is directly proportional to B max square. B max is nothing but E. So hysteresis losses directly proportional to E power 1.6. These formulas are most important for the competitive exams. So thank you for watching.